This meeting is being recorded.
Okay, in yesterday's class, we discussed about the lab. Basically, we did take two VLANs and we did communicate it between the VLANs using a router. And we were able to make that work using a router on a stick configuration. That is the first thing we did. And the second thing we did was having two switches and having a trunk between the switches and make sure we were able to ping between the switches in the same VLAN. We were able to accomplish that. So moving on to the next thing, we are not doing the lab today. We are going to theory. Do you guys want to see any other labs or do you want to move on to the theory?
We'll move on to theory.
Yeah, I think that is the right call because we did enough lab at the CCNA level. I think that should be fine. We'll do one more lab, maybe a little bit in the future by doing a little bit of OSPF, could be, or a little bit of ACLs, like that. But we got to wrap up or speed up on our theory as well. So today let's talk about some of the services that support on the CCNA syllabus. So, I mean, before we move on to services, we need to cover the OSPF, right? So let's talk about the OSPF today, and let's move on to the services. I think this is our 13th class, right? Or today is like 14th class, somewhere like that. So yeah, we are coming halfway through the classes. So we'll see how things go. Maybe give or take, it may take one more week extra, but I think we are okay. We are not like too lagging behind. We'll see. Okay, let's talk about OSPF today, guys. Before I start OSPF, do you guys have any questions on yesterday lab? Anyone? Okay, I take silence as no. Let's move on to the OSPF. So OSPF, guys, OSPF is a link state protocol. What is link state protocol? A link state protocol means it will check the type of the link, meaning like, is it a 10 gig link? Is it a 1 gig link? Is it a 100 MB link? Based on the type of the link, it will calculate the cost and it will select the best path to reach the destination. So we talked about a dynamic routing protocol, guys. Static routing versus dynamic routing. Who can tell me the difference between static routing versus dynamic routing?
So in static routing, we manually add the destination routes to the next hop. Where it comes to like dynamic, it will select the best path, which will make one as the active and the next one as backup. So once the active goes down, the backup will automatically become the active.
Yeah, couldn't summarize it better. Thank you. Beautiful job. So yes, so dynamic routing means it will select the best path based on any algorithm, and that will make it as an active route. And if that goes down, it will automatically select a backup path. We, as a network engineer or administrator, we don't have to worry about the failing over the network because the dynamic routing protocol will take care of that. So what is the full form of OSPF? Open shortest path. So what is open shortest path first? Meaning whichever path has the shorter path to reach the destination, that path will be first preferred. The name itself says, right? So OSPF is a open standard protocol, meaning any vendor will support it. It's not like a proprietary, meaning only Cisco supports it, or only Juniper, or only Arista, Aruba, anyone like that. It's an open standard protocol. Any device can support it. So that's the major advantage of OSPF, because any vendor will support it. And coming to the OSPF cost calculation, there is a formula for OSPF to calculate the cost. Okay, so let's see that formula. So the formula is cost equal to APPS divided by 10 to the power of, I'm sorry, link speed. Or cost equal to 10 to the power of 8 divided by link speed. Let's calculate this, guys. So let's say I'm in Connecticut, and then I'm in maybe Rhode Island, and I'm trying to go to Atlanta. So this is 100 miles. This is 1,000 miles. So which path is faster, or which path can be reachable easier, guys? Through Connecticut or Atlanta, through Rhode Island? Which one will be faster?
With the 100 miles.
Yeah,
Atlanta.
Connecticut.
yeah, Connecticut to Atlanta, right? It's just 100 miles, so that will be quicker. Similarly, let's say this is 10 Gbps, and this is 1 Gbps. So this is the link speed, guys. So, right? This is 10 gigabit per second. This is 1 gigabit per second. So let's calculate the cost for Connecticut to Atlanta. Connecticut to Atlanta cost equal to 10 to the power 8 divided by 10 Gbps. The link speed is 10 gigabit per second. So 10 gigabit per second will be cost equal to 10 to the power 8 divided by 10 into 10 to the power 7. That makes it cost equal to 10 to the power 8 divided by 10 to the power 8. That makes it 1. Similarly, calculate the cost to Rhode Island to Atlanta. Cost equal to 10 to the power 8 divided by 10 to the power 1 Gbps. That will be cost equal to 10 to the power 8 divided by 10 to the power 10 to the power 7. Cost equal to 10. So from Connecticut to Atlanta, the OSPF cost is equal to 1. And from here to here, the cost equal to 10. Which one is preferred, guys?
Cost is equals to 1 because it is less compared to the cost 10.
Yep. Lower the cost, higher the preference because of the link speed, right? So this is 10 gigabit per second. This is 1 gigabit per second. It's like having an internet speed, guys. You have an internet speed of 1 GB or you're having an internet speed of 500 MB, right? It's like having a more preferred link. So cost 1 is preferred than cost 10. So OSPF always works on what? Cost. So whichever has the less cost, that path is preferred in the OSPF. So you have to remember that. Okay. And what is the administrative distance of OSPF, guys? Anyone remember that?
110.
Yep, that is correct. So OSPF cost is OSPF AD value is 110. That is an industry standard that is defined when we are comparing two routes with two different protocols. For example, let's say we are learning 10.0.0.1/32 via EIGRP. And we are learning the same route 10.0.0.1/32 via OSPF. Which one is preferred, guys?
Via EIGRP.
Yep, because EIGRP AD value is 90.
90.
90 is preferred than OSPF 110. So when we have two equal routes, the router will select the best path, whichever has the lower AD value. Sorry, lower AD value. That is correct. What about this, guys? So if, for example, if I am learning 10.0.0.1/24 via OSPF, 10.0.0.1/27 via EIGRP. Which one is preferred?
OSPF because of longest prefix match.
No, EIGRP.
Yeah, the longest prefix match is the correct answer, but the longest prefix match is /27. Remember the formula 32 minus 24. It will make it as 2 power 8, which has 256 hosts. 32 minus 27 is equal to 5. 2 power 5 is equal to 32. So which one is preferred, guys? /27 is preferred because of the smaller group, which has the longest match.
Oh, sorry.
Yeah, but you understand the concept, right? It's maybe your calculation is wrong, but it's okay. Cool. Okay, so now let's move on. So, any questions till now? Okay. So OSPF is basically works in areas. Let's talk about the areas. What is an area, right? Let's talk about that. Before we understand the area, let's talk about a generalized term of separating the groups. Okay, let's talk about that here. Okay, let's talk about this. Let's say there is a big city, or let's say there is a big place. Okay, there are let's say there are n number of people in that group. Okay, so there is a let's say there is a big place and there are so many people, and let's say these are all interconnected. Okay, let's say these are all interconnected. Okay, when this person want to talk with this person, he has to flow through all the other persons. The message has to come to this guy. That is a lot of overhead, because we are, when I try to talk to this guy, I should be knowing his name all the way to me. So this is causing a lot of overhead inside the same network. So to avoid this, what I'm going to do is, let's take a big network again. Let's say there are like a lot of people like that, and there is another, let's say there are other people like that, right? So there are a lot of people. So what I'm going to do is, I'm going to make this into multiple smaller groups. And I will assign one leader to the group. One leader, let's say this guy is the leader. Whatever this group want to talk to any other person, I will talk to the leader only. And that leader will pass on to the message to his group members. Similarly, in this group, I will elect a leader. Whatever this group want to talk to me, my group, it will talk to only leader. So this way, the updates will be smaller inside the network, and we are reducing the overhead in the network. So if consider these persons are routers, and these letters are called area border routers. So any person, if it wants to talk to, I mean, this group is nothing but an area in OSPF. So any person outside, I'm sorry, any person outside of my area, if they want to talk to me, it has to talk through my leader, which is the area border router. So now let's put together as the OSPF concept. Okay. Okay, so in this case, this is router 1, which is called internal router, because it is part of only one area. Okay, and this is called area border router. This is like the leader in our example, area border router. Okay, that is the area border router. Okay, and these are internal routers again. And these are internal routers again. And this is area border router. So a area border router is the router which will be connecting two groups or two areas. So if I want to talk to from this group, if I want to talk to this guy, I cannot talk to him directly. Okay. I have to go to router. I have to go to the area border router, and from the area border router, they will talk to the actual router, because this will reduce the number of messages that are exchanged in the network. And there is a concept of backbone area. So what is the concept of backbone area? Means an area which connect all the other areas is called a backbone area. In this case, which is the backbone area? Area 0, area 1, area 2. So which area is the backbone area, guys?
Area 0 is the backbone.
Zero.
Area 0.
Yeah, because area 0 will be connecting all the other areas. Why do we need a backbone area, guys? Why do we need a backbone area? Because we need a backbone area to avoid the loops. So let's talk about the loop concept here. Okay. Okay. So let's say there is a person here. Let's say there is a person here. It's want to talk to this person. Okay. So when this person wants to talk to this person, it has to go through the backbone area, and the backbone area will be sending to this router. But this router, whenever it's learned the route via this guy, for example, this has one, right? So this route 10.0.0.1 route is sent to this router. That same route should not be sent from this area to the other area, because that route is not originated in this area. So let's say there is a person named maybe Ramesh. So Ramesh information is sent to from area 1 to area 2 via area 0. The same Ramesh information should not be sent by this area, because Ramesh is not part of this area. So this area should not send Ramesh information to this area, because what will happen, guys? Next time when this area wants to fetch Ramesh information, it will try to go to this area, which we don't want that. So the backbone area will use it to avoid this kind of duplication of information, and every area to talk to other area, it has to pass through the backbone area. That way, for example, if you have one area, one area, one area, and one area, and this is the backbone area, right? If we send the routes from here to here, and if this guy sends the same routes to here, and if this guy sends the same routes to here, what we have? We have a loop here. So to avoid that, the backbone area will sit in the middle. It will learn the area routes of the other area into the backbone area, and the backbone area know that that route is learned from area 0, area 1, or area 2, or area 3. So the backbone area will know where the actual information lives, so it routes accordingly. Any questions on this topic? This is a little bit of CCNP topic. The routing loops, CCNA does not need it, but I just went one step ahead. But did you understand the concept or not?
Yes.
Yes.
Okay, then that's good. Now let's talk about OSPF LSA types. LSA, what is LSA? Link state advertisement. Meaning? Okay, obviously, this is area 0, backbone. This is area 2. This is area 1. Okay, if the routers want to communicate inside the same area, they can directly communicate. They don't need a backbone router for that. So if I want to communicate inside my same area, that is used to use LSA type 1. LSA is nothing but a message. Okay. Use it to communicate inside same area. So I want LSA type 3. Summary LSA, meaning if I want to talk to someone else in the other group, I will send my info to the border, and the border will send that to the other member. So the message that I send to the border will be type 1, and that type 1 will be converted to the type 3, and that type 3 will be sent to the other router. So by that we know, oh, this is LSA type 3. That means this message came from someone in the outside of our group. It is not part of our group. So that is measured as LSA type 3. And there is LSA type 2, which is known with election of DR, BDR, DR, BDR. We'll talk about that in a minute now. But let's talk about LSA type 5. LSA type 5 is external link LSA. What is external link LSA? So external link LSA means when there is a routing domain outside of OSPF that is present. For example, this is all OSPF. Let's say there's another routing protocol, like for example, RIP. Okay, so let's say there is another router. Okay, so this router is running protocol RIP. And if this router, and if my router wants to communicate with this router, it has to go to AVR, and the AVR should talk to other AVR, and this one should talk to this router, and that one should send to the RIP. But how will I know that this route is an external routing protocol outside of OSPF? That will be known by LSA type 5, which is external link LSA. Okay, so what is this router called, guys? What is this router called? What is the router that is connecting two areas called?
Area border router.
Yeah, that is correct. Now, what is this router called? This is called ASBR, which is called Autonomous System
Border router.
Someone did their homework, right? Okay. Autonomous system border router, meaning there is an area, there is a routing protocol that is connected outside of the OSPF, and that ASBR is saying that, okay, to reach that RIP protocol, you have to pass through the ASBR. So all these routers inside the RIP can run RIP, but when they want to talk to OSPF, they will use this ASBR router, and that is done by LSA type 5. So when this router sees that there is a LSA type 5, that means that, okay, there is a router that is having another protocol, and I'm seeing LSA type 5. It is a redistributed route. We'll talk about what is redistribution. When we talk about a little bit of BGP, we'll talk about redistributing of routes between the protocols. But redistribution is nothing but conversion of route from one protocol to the other protocol. For example, if you are a router and you're talking OSPF, and if I am a router, I'm talking EAGRP, we both have to understand what we are talking. So to make them understand, it's like a translator. It's a redistributed route between both the routers. That's a different concept. We don't have to go into that now. So we talked about LSA type 5. Now let's talk about LSA type 4. LSA type 4 is nothing but it is an identifier to the ASBR and provides a route to the ASBR. What is that? So let's say in the same example, let's take a different color. If this router wants to talk to this router, what is the LSA it uses, guys? This router? Managna, can you tell what is the LSA that this router uses to talk to the ASBR?
As both are different protocols, is it LSA type 5?
Correct. This uses LSA type 5. The LSA type 5 will be used to communicate from this to this. But if this router wants to talk to this router does not know the information of this router because it has to talk to my ABR. You remember I said, if I want to talk to something outside of my group, I have to talk to my ABR only. I cannot talk to directly that router. So in that case, let's say there is a person here called Suresh. Okay, I want to reach Suresh. This router wants to reach Suresh, but I don't know where Suresh is. I will ask, where is Suresh, to my border router. My border router will say, I know Suresh, use LSA type 4. So what is this router doing? It is providing a route to this ASBR router. So area border router will provide a route to the ASBR through LSA type 4. So if this router wants to talk to this router directly, it cannot reach it directly. It has to talk to the ABR, and ABR will provide what LSA? LSA type 4 to tell him how to reach the ASBR. So let me write that down. This is also a CCNP concept. It is generated by ABR to provide a route to ASBR when a regular router is trying to reach outside of area. Clear, guys? So LSA type 1 is used to communicate within the same area. Type 3 is a summary LSA between the areas. Type 5, external link LSA to talk between the areas. Not between the areas, my bad. It is to talk between two different protocols. Type 5. Type 4, it is generated by ABR to provide a route to ASBR, where a regular router trying to reach something outside of its area. For example, maybe a RIP protocol or EHRP outside of its routing protocol. That is about LSA types. There are different LSA types like type 7, which is not so stubby. There is also stub area, but I don't want you to get confused on these areas yet. When you learn about CCNP, you will learn more into what is a stub area and what is a not so stubby area. But I'll generalize that stub area is an area which will only receive routes, but it will not send any routes to back. It uses stub area, it will uses like, when you have that, it uses like something like 5, but also it will only receive routes. We'll talk about that later, but for now, LSA type 1, type 3, type 5, type 4. Okay. We also need to talk about type 2 because type 2 is also important. Let's talk about type 2.
I have a doubt.
Go ahead.
So, as you said, the before example, if there is a router in area 1, if it needs to communicate to the router in RIP protocol. So does it like it has to go through the 2 ASBRs and then it has to route to the RIP, right?
It has to go to 2 ABRs.
Yeah, 2 ABRs. And does that come under type 5 or type 4?
If a router is in area 1, if it's want to talk to the router that is running RIP that is connected to area 2, just like in our example, in that case, the area 1 router will use type 4.
Okay.
But if the router is in area 2, if it's want to talk to something in that area, it will use type 5.
ASBR.
Okay, yeah, got it.
Okay, I think let's talk about LSA type 2 now. Okay. Before we talk about the type 2, let's talk about if I want to talk to my neighbor and if my neighbor want to talk to me, we need to form a OSPF neighborship. I cannot directly send a message to my neighbor, or my neighbor cannot talk to me directly unless we form a neighborship. It is true for all the cases. This router have to form an OSPF neighborship with this guy. This guy has to form neighborship with this guy. So we have to form an adjacency between 2 neighbors. So let's talk about how do I make the neighborship. Okay. Let's talk about OSPF neighborship states. Yeah. OSPF router 1, OSPF router 2. Okay. So it has to pass through 7 states. Lot of theory, guys, lot of theory. So it has to pass through 7 states to understand the full, to make the full neighborship between the routers. So in the down state, both the neighbors will be not talking and they will not start trying to form the neighborship, right? So in the first state, in the down state, both the neighbors, they don't want to form any neighborship. They will be just sitting in the down state. Okay, so here in the down state, what does this do, guys? The neighborship process did not yet started. Okay. What is attempt state? As attempt state is, it's trying to send the packet now. Trying to start sending first packet. What is attempt state does? What is init state? I think it's initial state. There's a typo. Init, initial state. What is initial state does? So let's say this router send a packet to this guy. So in the init state, the router 1 sent packet to router 2, but router 2 didn't responded yet. So in the init state, the router 1 sent the packet to router 2, but the router 2 did not responded yet. In two-way state, router 2 sent a hello back. The name itself says it is a two-way. So in the state of two-way, this guy responded back. Okay, Xstart state. In Xstart state, they both start negotiation. By validating content. Exchange state. They both start exchanging their database. In loading state, it will router will calculate the router will form the best path in routing table based on information in database. Okay, in full state, they are fully exchanged info and neighborship is successful. So what does this mean, guys? So in the two-way state, after they both exchanged hello messages, they will start negotiating the content, meaning, are you the DR or am I the BDR? Meaning DR means designated router, BDR means backup designated router. So what is that means is, let's say, three routers. So this is a three route. This is a three routers, and this one form the neighborship with this guy. This one want to try to form the neighborship with this guy. This one want to form the neighborship with this guy in the OSPF, right? So this router should know which one is the DR and which one is the BDR, because let's say it has a route of 10/0.0.0/1/32. This router is sent to this router, and the same route will be sent to this router. And this router will send it back to this router. So this router should know, okay, I received this router from two routers, router 1 and router 2. Which one should be considered? Which one has more priority? To elect that, to avoid this looping formula, they will form the DR and BDR. DR, BDR. So in this network, so when this is the DR, when this is the DR will send the routes to other neighbors, but the BDR will still sit silently. So when this one sends the routing to this guy, this one will never send this to this guy, because this is a backup router. This is not a designated router. So the communication between the DR and BDR is done using LSA type 2. So earlier we were talking about LSA type 1, but we did not talk about LSA type 2. The LSA type 2 is used in the communication of election of DR and BDR. That will be done at the two-way state. So two-way state is where they both exchange the hellos, and in the XStart state they will be negotiating like who is the DR and BDR. And how this is elected, guys? By a value of priority. Higher priority will become DR. Let's compare this with spanning tree, guys. In the spanning tree, will the higher priority wins or lower priority wins?
Lower.
Lower.
This is opposite to the spanning tree. Here, the higher priority wins. What if priority match? In spanning tree, what if the priority match, guys? What will happen?
We'll check the MAC address.
Yes.
And what will win? Lower or higher MAC address?
Little lower.
Yeah, here the higher IP address will win. If the priority matches, the higher IP address will win the election. So it's opposite, because it's a layer 3, it's a router, it will consider the IP address. So whichever has the higher IP address, that one will win the election. Okay, so let's talk about the exchange state. So in the exchange state, they both start exchanging their databases, meaning it has, let's say this has this area. I mean, this router has other router connections, other server connections, something like that, right? Maybe a switch connected here. So it's shared its database to its neighbor. And similarly, this router will share its database to this neighbor. So in the exchange state, they start exchanging the databases. Loading state is where, so okay, let's say this router and this router has best path. For example, there is a router here and there's a router here. So to reach this router, it will share its database to this guy, and this will know, okay, so to reach this router, I have to use this router. So that calculation is done in the loading state. And the full state is where every routes are synchronized. So this router will know all the other routes of this router, and this router will know all the other routes of this router. So in the full state, they all be successful. So when someone asks in the interview, what are the states of the OSPF, you have to tell these states and you have to explain a single line about each state. Okay. and there is a question that they ask in the interview, or you might similarly, when you're turning on the OSPF between the neighbors, you might get an issue with OSPF stuck in X start state, X start or exchange state. Usually this happens in the real time. People will ask you, what will you do when your OSPF stuck in X start or exchange state? It is not getting fully adjacent. Then you have to check the MTU of the interface and MTU on the interface. If the MTU does not match, what will happen, guys? Tell me, what is MTU? MTU is the maximum transmit unit. Meaning that will tell how much data that a packet can carry. For example, if your data has 7 routes, and if your MTU is 1500, all 7 routes are sufficient to send in 1500. Let's say the other router has MTU 100. So when you send 7 routes, if the other router is having only MTU 100, it cannot load all 7 routes. So there is a MTU mismatch. It's just like, let's say I gave you a message and you cannot hear the full message. You are getting full, so my message is broken. Let's say I'm trying to convey you a message that has 4 important pieces. Let's say I conveyed a message to you that I joined a class, I listened to the class, I did the lab, I completed my class. But once you get the message you already got, I joined the class, my message is broken, then you will not understand my entire information. So if there is a mismatch in the MTU, the messages are not fully exchanged between the routers. In that case, what will happen, guys? The databases will not be exchanged and the OSPF neighborship will not form. So that will happen in the real-time world. So you have to make sure the MTU is matching on both sides. Any questions still there? So this is when there is a router and there is another router, and if you are trying to form a neighborship between them, here in this case, do we need a DR and BDR, guys?
No,
Yes.
No,
because there is no way of loop.
There is no loop here. Very good answer. Because there is no loop. So there is no need of election of DR and BDR because there is no loop. So this is called point-to-point OSPF network. When there are 2 routers, there is no election of DR and BDR because there is no loop. There is no loop. Okay. So let's summarize today's class, guys. What have we studied today? Let's do a quick round of class. Monica, can you tell me what is the AD value of OSPF? Okay, pass on to the next one. Gopi, can you tell me what is the AD value of OSPF?
110.
110. That is correct. Okay. Hari, can you tell me what is the type of OSPF protocol? Is it a distance vector or is it a path vector? Is it a link state?
State protocol.
It is a link state protocol because it will calculate the best path based on the link cost. Manogna, can you tell me how does the OSPF calculate the cost?
So it's 10 to the power of 8 divided by the link speed.
Yep, it is divided based on the formula algorithm with the 10 power 8 divided by the speed of the link. That way we get the best path. Is it the lower value is preferred or higher value is preferred?
Lower value.
Okay, yeah, lower value is preferred. Mahit, can you tell me in OSPF, if there is a MTU mismatch, what state it will be in? What state it will be in stuck?
Start on exchange state.
So it will stuck in extra or exchange state because there is a mismatch of the MTU. They both cannot understand the full description of the packet, and that's why there is a breakage in the communication. Sudhir, Nita, can you tell me how does OSPF elect the DR and BDR?
When they have multiple loops, like when they have like 3 rotors.
Okay, how does it elect?
Like in a two-way state, it elected by a value of priority, like higher value of priority. Priority wins.
What if the priorities match?
They check the IP address, and the higher priority, like higher IP address, wins.
Correct. So it will check the OSPF priorities, meaning like there is a priority that is manually defined, and whichever has the higher priority, that will become the designated router. And if the DR fails, there will be a backup designated router to send the update to the neighbor. And can anyone tell me OSPF works on which type of communication? What it uses to communicate with its neighbor?
By alloy packets?
Hello packet is to form to the neighborship, but what is the information that what is that called to talk to its neighbor?
Discovery mechanism?
It is called LSA, link state advertisement. So OSPF neighbor will talk to its neighbor based on the LSAs. It is called link state advertisement. Okay, let's do Hari. Can you tell me if the routers are in the same area, which LSA type it uses to communicate inside the same area?
LSA1.
It uses LSA type 1. Sai Sri, can you tell me if the routers are in 2 different areas, what will the border router use to communicate the information?
Sorry, I didn't get that. Could you repeat for me?
When the routers are in 2 different areas, what will be the message that is generated by the border router? Which type of LSA?
LSA 3.
Yeah. So the area border router will send the type 3 message to communicate with its other peers outside of that area, which is acting like a border router, right? Okay. Manogna, can you tell me what is an ASBR?
So it is a autonomous system border router.
What is it? What does it do?
So it's related to type 5 when there is like when we want to route something in outside the area and which is in a different protocol.
Yeah, ASBR will connect an external routing protocol other than OSPF. It will connect to the OSPF. It is a router that is connecting a different routing protocol. That is correct. Monica, what LSA that is generated by an router to reach the ASBR?
Type 4?
Are you sure?
Yes.
Well, think about it. If my ASBR is in the same area of me, will I use type 4?
Type 4 will be identify the route to the area.
Let's talk about it. If this router want to talk to ASBR, what LSA it uses? You're saying type 4?
Yes, sir.
That is type 5.
External link.
Yeah, type
Yeah.
5 is if the router wants to talk to something that is connected to the ASBR,
Outside of the.
that will be type 5. Okay. But if this router want to communicate, it has to talk to what? The area border router. The area border will send the type 4 to this router to reach the ASBR. So this is type 4.
4.
This is type 5.
Type 5.
Clear?
Yes, sir.
Okay, good. I think that is it about the OSPF. We covered OSPF in detail as much as we can. But OSPF is like a book. You can dig deep, like 3,000 pages only on the OSPF itself. If you want to go deeper and deeper and deeper and deeper, it is like a subject itself. But for CCNA, we just have to understand the base level concepts of OSPF. We'll stop the recording here and we'll open the floor to any questions.